Hello and welcome to the 5th video in this tutorial series on how to make a Planet Defense game with Hexflixel. In this tutorial we will be creating the bullet class and drawing a bullet which can destroy enemies. But before we do that, I'd just like to fix up something from the previous episode. We created this animation, the idle animation, but it was never actually visible in the game because I forgot to write here in the update method animation.play idle. But that simple line will fix that. Now let's move on to creating the bullet. So in your source folder, create a new file and save it as B bullet.hex and write package semicolon to put it in our project, and then write class bullet extends FlexByte with opening and closing curly brackets. Now of course we used FlexByte, so we have to import that. Now let's write our new method, so write public function new. Now our bullet, first of all it takes an angle, so the angle it should, obviously face. So let's just put underscore angle here. The reason we put an underscore there is because if it was just angle, our code wouldn't know whether it was referring to our bullet's angle on the screen or whether it's the angle that we passed in as an argument. Underscore obviously implies that this we're referring to the argument. We need an X and a Y, and we'll make them capitals for the same reason as putting an underscore here. And let's also take a velocity X and a velocity Y. Yeah. And now we can write super and X, Y, capital X, capital Y, and a semicolon. Now let's load the graphic. So load graphic, and let's open up Pixel Edit or whatever editor you like to use. Here I've just got a 5 by 2, so 5 down, 2 across, little golden rectangle thing. Just save this, so file, export, export image, and we can export this in our game projects folder, Planet Defense, assets, images, as B bullet.png, and save that. Now in our code we can refer to it as assets/images/bullet.png, and we have to set animated to false. Now we want to set the angle, so the rotation of this sprite, to be equal to underscore angle, which is the argument here. And we want to set our velocity, so we can just say here velocity dot set, and then Vx, Vy. So here we're referring to the velocity, so the speed of the sprite on both axes. So that will basically mean that we can change the speed that our bullet travels, which should obviously be in relation to this angle. Now, one other thing we want to do is, because this is a bullet class, we don't want it just remaining around infinitely in our game, because we might have hundreds of these, and if we keep on creating more, then it will fill up our memory. So to fix that, I'm just going to resort to a simple method, and that's just remove it based on the timer. So after 3 seconds, get rid of the bullet. So to do that, I'm just going to import the timer class. So import flixel.util.flexTimer, just like that. And then down here we can say new FlexTimer, and then in its arguments list we can say, I think its first argument is, So the time, so let's say after 5 seconds, that should be more than enough for a bullet to leave our screen. And the callback, so this is the function that's called when our timer finishes. So let's just say function. So we're actually going to type our function inside the argument list. We could create a new, on timer complete function, but just passing in what's called an anonymous function here works just as well. Now this function demands that it takes one argument called timer, or t, or whatever you want to call it. And then in here we're just going to say after these 5 seconds has elapsed, just kill this sprite. So it removes it from the screen. Just like that. Now that we've created the bullet class, we have to actually put it in our game. So if you go back to the playstate class, let's create a new group. So you can just duplicate the enemy group and change it to bullet group. Then here we can say, let's put the bullets at the top of our code. We'll put it at the top of our code. So basically the significance of putting it up here, still below super.create, is because this runs in order. Basically our planet is in the background most, then we add the enemies, and then we add the player. So that means if the player and the enemy were overlapping, you would see the player on top. And so let's add the bullet group right at the top, which means that it will go underneath any of our other objects. So add bullet group. Now something we did in a previous episode when we were setting up the controls for the player was we said if shoot key. Now we're not actually going to be managing the bullets in the player class, so we can actually move all of this code out and into our playstate class. So in the playstate update method, we can move this here. So we can just cut this. I'll show you what I cut in just a moment. It's in the playstate method. In the playstate class, under the update method, we can have var shoot key equals flexg.keys.anypressed up W or space. These keys will cause a bullet to be fired. And then if shoot key, so we could easily have just put that there, but I don't think it's as clean. So here we say the player should shoot. So we can just say bullet group dot add B. Now B doesn't exist at the moment, but basically B is the bullet that we're just about to create. So we can say, actually let's not do that, let's actually put a new bullet inside here. So new bullet. So we're saying with our bullet group, add a new bullet. It wants an angle x, y, velocity x and a velocity y. Now to get these values, first of all the angle will be exactly the same as the player angle. So we can just say player dot angle. For the x, we can say player dot get midpoint. So get the middle of the player, that position, and then get the x, because that can also store a y. That's a location variable. For the start y, we can just say player dot get midpoint dot y, so that gets the y axis position on the player. And for the velocity x and the velocity y, we're going to be doing something a little bit different. We're going to have to use a little bit of trigonometry, but it's super basic. And I think I've changed my mind on something. We're not actually going to pass in a velocity x and a velocity y, because we can work that all out based on this angle. So we can actually, sorry about that, just change the arguments to be angle xy. And then here, inside our bullet class, so this is what it looks like in the playstate method. bullet group.add new bullet player.angle player.getMidpoint.x and player.getMidpoint.y. And then in our bullet class, we're going to do some simple trigonometry to work out our velocity. So here we can just say Vx, actually there, Vx equals math with capital M, which is a hex class that stores lots of the more complex maths functions. And then in here we can just say maths.sine, and then it takes the angle. Now I'm not sure, but I think that the angle it takes is as a radian, which is kind of like an angle, but you know, there's 2 in a full circle. So to turn that into radians, I think we can just say times, and then in brackets, oops, whoa, times, and then in brackets here, math dot pi, capital P, capital I, divided by 180. That's how you convert an angle to a radian, and we pass that into the sine function to get the velocity x. Now we can do the same, but for velocity y, and we change sine to cosine. Now this is fine, but if we run this, you'll see that the bullet moves extremely slowly. So we need to change that with a speed variable. So above your new method, put a new variable, so var, and call it speed. It's of a type float, so colon float, and let's just set that to be a number like 50. And then we times both of these values by speed. And that should work. And then we set the velocity to be our Vx and Vy. Now we actually should be able to run it if everything is working fine. Let's just see if we get no errors. Hopefully we don't. Right, here we go. Oh, something's interesting is happening. Perhaps we've got this around the wrong way. Let's just try changing cosine and sine around. Right, there we go, we've got it. That was the problem, but obviously he's shooting to his right. We want him to shoot out. So to fix that, we can just subtract 90 from our angle. So minus 90, and hopefully that'll make him shoot up. There we go. Alright, obviously we've got an error. It's quite amusing though. Oh, right, so we need to put this in brackets, angle minus 90 in brackets. That was quite a funny bug. This has happened before in this series. It's quite annoying. You've got to have these things in brackets, otherwise the order of operations means that like minus 90 is being multiplied by this. It's all very confusing. There we go. Yay, we finally got it working 100%. It's shooting out when we press space. Now obviously, as you can see, it's shooting a whole load of bullets, and they're not killing the enemies. So let's fix both of those problems now. So first of all, in our update state, let's create what I like to call a manual timer. So basically, we're not going to be using the hexflex or flex timer method, the class. We will be creating our own, which is fairly simple. So in here we can just create a new variable, and let's call it recharge. Actually, let's just call this reload timer, and this is of a type float, so colon float equals 0. So basically, every single frame, this will go up by the amount of seconds that have passed since the previous frame. So you might not fully understand that, but just say in our update method, reload timer plus equals flexg.elapsed. So that's saying increase the reload timer by the amount of time that's passed. Then here, where we shoot, we have to say if shoot key, then do this. If reload timer is larger, and then here we have to put the amount of seconds we'd like to have between each bullet. So I'm just going to put a really small number, so it's quite rapid, here such as 0.2, which means 5 bullets a second. That might be too fast, but we'll see. And then you put the bullet creation code here, and we have to set the reload timer to be 0. So let me quickly revise what we've done. We've created a reload timer, which is equal to 0, and that stores the time since we last fired. So obviously it starts at 0 because we haven't fired. If that's larger than the reload timer's requirement, so if the amount of time that's passed is more than 0.2 seconds, then reset it to 0 and add a bullet. Now if we execute our code, we should have limited, we should only be able to fire so fast. There we go. As you can see, it's really slowed down the speed that our bullets can shoot at. It's still extremely fast, but you know, even if the player was walking around like this, you know, it's still not too easy. So now we want to make sure that these bullets destroy the enemy. So in our update method, we can just create a collision check. So underneath all of this shooting stuff, we can say flex G. For this episode to work, you've got to make sure you've imported that with import flexor.flexg up the top of your playstate class. It should automatically be there. Flexg dot overlap. So if these two things are overlapping, so the first thing we want to check it against is all of the enemies. So enemy group. If enemy group is overlapping, if any of the enemies in that group are overlapping with any of the bullets in the bullet group, then call this function. And this function has to have two arguments. The first one is the enemy, because we put that as the first argument here. So we can just say enemy there. Actually, let's just put that as E. So we're making sure that we're referring to the overlap, you know, this enemy and this bullet, and B, and also because they're short. Now we have to put our opening and closing curly brackets and put a semicolon there. Now what do we want to do if the enemy and the bullet collide? Well, first of all, we definitely want to kill the enemy because they've been shot. Gosh. And we might want to kill the bullet as well. Oh, sorry, this should be e.kill because we're referring to this here. So we kill the enemy and we kill the bullet. If you wanted to make it so that bullets could fly through enemies, then you could, you know, obviously also just not remove the bullet. So now, if we find an enemy somewhere, well, it's not working. either I haven't saved this file or... No, that should work. I mightn't have saved the file, but let's see. Something might be wrong. Right, so here's an enemy. It's definitely not colliding with it. Okay, so I worked out what the problem was. It's actually kind of difficult to know this, but there's a certain boundary that all collisions have to happen within to register, and that was too small for our game. So it's super easy to change it. I just didn't know that it was so small. In our playstate file, in the create method, at the very bottom, just put flexg.worldbounds, so the boundaries that collisions have to occur within, dot set size, and then I just set that to be two large numbers, 1000 and 1000. And after running, it seems that everything works fine. All of the collisions work properly. So obviously, all of our game is needs to be within these collision bounds for collisions to work properly. Now when we run the game, these bullets should kill the enemy and the bullet. If you put b.kill there. Yep, and it kills all of them. So there you go. You can have bullets in your game and they can destroy monsters coming towards your planet. We've got a super bare bones, obviously very bare bones planet defense game here. Doesn't have scores or anything, but they're all things that we can have in future episodes. Thank you for watching.